Okay, here's the quiz review, Savannah. All right. So the first problem on your quiz, I don't have a quiz review in front of me, so you might have to give me the reference problems I gave you as we go through. But the very first problem on the quiz says the figure shows the velocity v equals dSdt, so you're looking at a velocity curve, much like the one I asked you to look at on your quiz review. And it says, sketch a graph of the acceleration where to find. You did that. What is your graph going to look like? A series of horizontal segments with open or closed things at the end.
Open.
Open, because when you've got a choppy curve that goes like that switches immediately from one thing to another like this. These switches right here can't have derivatives. So when you're graphing a derivative, which is acceleration, at these locations, you can't have any values. So the graph of this curve would be a series of horizontal line segments. And where one breaks to go to the other, they both got to have holes at the end. It says there's no derivative at that point. Do you have open or closed holes at the beginning and the end, or are they also open?
Well, also open.
The answer says it doesn't matter.
Oh.
But the intermediate ones, the one between this slope and this slope, has to have holes at the ends of both of them because there is no derivative there.
So
At the actual endpoints, I don't care what you do with those. What?
So we're graphing the.
You're graphing. This is a velocity curve. You're graphing acceleration.
So could we just put the velocity? Does it give us an equation for the
No,
velocity?
it gives you a picture.
So we start with a closed line. Closed.
It's going to be something like this. Start over here at 0, perhaps, and maybe the y-axis or the x-axis is here. And you've got, let's say that this is 2, 3, 4, 5. This isn't very well done, sorry. 6 and 7, we'll say. Makes it look something like that. How are you going to draw the acceleration curve? Well, it's going to have the exact same x's because this is time and it has the exact same x values. 1, 2, 3, 4, 5, 6, 7. What is the slope from 0 to 2? Because that stays the same from 0 to 2. What is that slope?
0.
That's what you're graphing is slopes. So it would go from here to here, open, because right there it changes hard, changes fast. What is the slope of this? I guess I better mark this. Let's say this is 0. That would be -1. So this is 1, 2, 3, 4.
So -2.
So yeah, this is dropping from 4 to, we'll pretend that's 2. I realize this isn't great because I superimposed the grid over the top of the curve. So let's say this drops to 2 right here. So it's going to drop. It's going to drop 2 and run 1. So that slope is -2. So you come down here to -2 and start 1 there, and it only goes 1 unit long. But its slope is -2 for that period length. Y'all following? And then it does what?
0.
Goes to 0 from 3 to 5 again. So we're here. This is kind of a boring one, but I'm hoping you can see what's going on. And then this one drops from 2 to 3. I'm sorry, 2 to -1. So that's a drop of 3 run 1. What's that? -3. So we put this one down here. And then this one goes from -1 back up to 2. That would be a slope of 3. So up here at 3. From just 1 unit long, and I don't care what you do at the ends. Hole, closed, I don't care. But this better be a hole, and this better be a hole. And because of the reason why is because there's a corner on the velocity function at 2. There can't be a derivative there, which is what you're graphing. You following? Okay, so that's number 1. And so number 1, if you can see your answers, it's a graph you have to produce. It's got the same x values as the original. So number 1 looks like that. Okay. Number 2 says, in which of the following time intervals is the body accelerating. So you're referring back to your to your picture of number 1. It says, in which of the following time intervals is the body accelerating? And then it reminds you that there is a difference between accelerating and decelerating by saying, in parentheses, a greater than 0. So when you're accelerating, it's when the acceleration, because it can be a signed thing, it's a vector, acceleration is. When you're accelerating, we assume that that word means positive. So where is this thing accelerating? From 6 to 7, and that's it. That's the only time acceleration is positive.
Wait, if you had a graph that was like below the x-axis, but was still going up, would that still be accelerating?
Yes?
Okay.
Slope is positive.
So right here, this accelerates from -1 to, well, it accelerates from 6 to 7 seconds, but it goes from an acceleration or a deceleration of 1 and arrives at 2. It's still accelerating at a rate of 3.
Okay.
So the acceleration is positive in only one region of this, and that's from 6 to 7.
It's only if that one is positive.
What's that?
It's only if that one is positive.
Yes,
Okay.
because this is the acceleration curve.
Okay.
So if you want A to be greater than 0, you're looking for those chunks of lines that are above, not at, but above. This is neither accelerating nor decelerating. The object is moving, but at a constant rate here and here. You see?
Yeah.
Okay. Slowing down here, speeding up there, and that's what we're looking for is an acceleration. Slowing down here as well. You can tell that from the graph because they're below the y-axis or x-axis. Okay. The author does offer you your choices on this one. He does do stuff like this. For example, he might say, and the answer is from 6 to 7, but he chooses to close the endpoints. I don't care, but if you choose this one, and which is correct, you need to choose the one that's got the bracket on it. Don't let that bother you. Endpoints can have brackets because they can be closed. He likes that. The author likes that. So if you choose an end segment, either this one or this one to answer your question, it may have a bracket on the right or left. Don't let it worry you. Look at the numbers. Okay. Number 3 says, suppose the dollar cost of producing X cassettes, I don't know what cassettes or what are, but we're producing the X number of cassettes is, and it gives you a cost function, and it says, find the marginal cost when 50 cassettes are produced. What do you have to do? What does it mean to find the marginal cost?
The derivative of the cost.
They give you the cost function. You have to find the derivative of it. You could enter it. Yep. You could enter it and evaluate it at that value. At 50. I say 50. It's not what it says here. Okay? And your choices are all dollar amounts. Do we need to go over that?
Just one example.
Okay, yeah. Let's do it.
One warning about this, and this should no longer be an issue for any of you, but I suspect that it might be. The cost function is a sum of rational functions, meaning you got fractions to deal with, like this. The cost function that you're given might be something like this. How do you find the derivative of that?
Hour.
Find the power
First.
second.
So what do I get?
6x.
Really?
Oh, plus 2 over 10x.
Because then we have to do the quotient rule.
You could, but I wouldn't.
Move the 5x to negative 2.
Yeah, I would rename this before doing the derivative like this. Oh, sorry. That's wrong. Only the x gets to come up.
Oh, really?
Yes, because it's the only thing affected by the power. 5 is not being powered. So x to the x squared comes upstairs and it's going to be x to the negative 2, but the 5's got to stay.
And just do negative 1 on it.
Yeah, but that would be silly.
Okay.
For the number, that would be silly. Okay, so do you understand the rewrite here now that I've got it correct?
Yes.
So now let's find the derivative. And this is that people get hung up on this all the time because they have this derivative, this part right here, they do just what you did. Gotta be careful. And you could apply the quotient rule and it'd give you the same thing, it's just that it opens up more opportunity for error. Okay,
Sometimes
so what's C prime of x? 6x minus 4/5, or you can leave it x to -3, I don't care. And then you would evaluate that at the number of cassettes that you're gonna produce to get a dollar amount. Or enter this at 50. But then you've got nothing to show me in case you get it wrong.
I don't like that.
You could use enter to check,
Oh, you missed a lot, Sam.
but I would show this if you want to give any indication you know what you're doing. I would give you credit for the correct answer if you get it. If you get it wrong, I'm going to be looking for this, and if I don't see it, you're going to miss it all.
Okay.
Everybody clear? Okay, the next one. Number 4 says find dy dx if y equals. And y involves a couple of really nice trig functions, but I'm not going to tell you which of the 6. There are 2 of the 6 involved, so you need to know all derivatives of these trig functions. Hopefully by now you've had enough experience with it that they are committed to memory pretty well. So this is a sample of what we're looking at here. When I say simple, I mean written only in terms of x. There's no chain rule or anything here. This is just a test to see if you can do derivatives on trig functions. So it'll say find dy dx if y is equal to something like this. Y is equal to cosecant x minus tangent x. Something like that. It'll be something like that. And they want you to find dy dx. In this case, it would be
Negative cosecant tangent.
negative cosecant tangent,
Cotangent.
cotangent,
Plus cosecant squared.
plus,
Minus.
minus,
Well, isn't it
Secant
minus
squared x.
secant squared.
If I thought about it for the whole.
Jacob.
Do you think that we could simplify that? And the answer is it doesn't matter because this is the type of answer you're going to be choosing from for your 5 solutions.
Or we can just make up a value for x and plug and check. Because if I say x equals 1, and then, you know what, I'll just keep that secret to myself. I'll just do that.
All right, as long as you're pretty sure it works every time.
It does work every time.
So do you understand that this number 4 is just testing to see if you know your 6 derivatives?
Yeah.
So know them. No cheat sheet, know them. So that you can just do it, and then what you get doesn't need to be attempted to be simplified trigonometrically or anything. Just write the derivatives. Make sure you got the proper signs on them, stuff like that. It's just a test to see if you have them memorized. It's not trying to sting you or get you in trouble or anything. Just if you have memorized, you'll get it right. If you don't, you won't. Probably. Number 5 says, this is one where you gotta be real careful. It says, find an approximate equation of the line tangent to the graph of y equals, and it gives you this function at a particular value. And this function that you're given involves another trig function. Something like this. When it says find approximate values, these are all lines of the form y equals mx plus b, but your m and your b are decimals rounded to the nearest hundredth, which is a good thing for you if you know how to handle it. So something like this. Y equals 2x squared secant x. Something like that at x equals pi thirds. And the instructions are, this is the information you get, the instructions are, find an approximate equation of the line tangent to the graph of y at pi thirds. People miss this all the time. It's because when they go to write the line, they screw it up. Believe it or not, it's the line that causes the problem, not the calculus. So, and it has to do with that storing the value. making sure you don't use an approximation till the very end kind of thing. That's what it's about. Okay, so what we need is a point, which we know the first piece of. The point is pi thirds comma something, and you got to plug that into the original to find the y to go with it, yeah? Okay, so what I want to know is, what is the y value if I take 2 times pi thirds squared times the secant of pi thirds? Now, I'm not sure this is going to work out because that's pretty ugly. But it might require a storage value. Might want to do a storage value. So this is equal to, yeah, pi squared, 2 pi squared over 9. And this is 1 over the cosine of pi thirds. What's the cosine of pi thirds?
What is the cosine of pi thirds? Yeah. 1/2.
1/2. And so we get pi halves over 9.
Pi squared.
I see.
Yeah. I wrote it right, said it wrong. Pi squared over 9. Do you all understand that this is a half? Do you see why that is or not? You think about a stand-up triangle at pi thirds in the first quadrant. The cosine is the short leg, which is a half.
It would be 2 over 1 j times 2.
What?
It's secant, not cosine.
Oh, yeah. So it's times 2, yeah. Good catch, good catch. So this is 4. Nice catch, that was good. So the y value is 4 pi squared over 9. I recommend you leave it in that form until you're ready to evaluate it at the very end. We okay? To there? Now we've got to derive y to find out to figure out what the slope's going to be. Yeah? Okay. So the derivative of y, put it right here so that Savannah can keep saying it. What's the derivative of y?
2x squared times whatever.
2x squared. 2x squared times 4 pi squared over 9 plus 4x times secant. 4x secant.
What are you talking about?
What is it? Never mind.
We're finding the derivative
Of y. Yeah.
Yeah.
Here's why.
Yeah. That.
So it's do the product.
Yeah.
That's what I just did.
Okay. But people forget the product rule here. And what you said made no sense to me at all. So try it again. Now that we all know you're talking about the product rule, give it to me again.
Okay. 2x squared secant tangent plus 4x secant.
Does that seem right?
That's not at all what I said before, though.
Okay.
No,
Well,
yeah.
good. I'm glad I redeemed myself. 'Cause I was going-
Y and X.
So y prime at what? What are we evaluating it at?
Pi thirds.
So without writing another line, I'm going to put pi thirds here, just to remind me, pi thirds here, and pi thirds here, pi thirds here, pi thirds here, and pi thirds here. That's going to be 2 pi squared over 9. Do you agree?
Yes.
What's the secant of pi thirds? We just did this. 2. What's the tangent of pi thirds?
Square root of 3. Root 3.
Is it?
Yeah.
It is root 3 over 2 over half. So that's root 3 over 2 times 2 over 1, which is root 3. Plus 4 pi thirds times 2. That's 4 root 3 pi squared, good grief,
Over 9.
over 9 plus 8 pi thirds. Now, at this point, it probably wouldn't be a bad idea to figure out what the decimal is for that, but I would store it because you're going to have to distribute that nasty decimal through the line that we're about to write.
I hate this.
What?
So y prime of pi thirds, we've got that right here. I'm going to call it m so that we can remember when we write the line what we're doing. And I think I'm gonna come back this way to write it because Savannah can still see. It's going to be y minus 4, well, I'm gonna go ahead and solve for y as I do this. So it's gonna be y equals the slope, which I would store it in something. What are you gonna store it in? A. So we're gonna call that A. So when you go to figure this out, it's gonna be y equals A times x minus pi thirds plus 4 pi squared ninths. We're storing it in A, the slope.
And we don't want to round it. Got it, okay.
So if I continue to do the math on this before I actually calculate anything, it's gonna be y equals ax minus a pi thirds plus 4 pi squared ninths. This is where you have to be careful to get the right value. So now we can say y equals, and whatever a turned out to be, you can now round it. For this term, you can round it to the nearest hundredth. But if you rounded it to the nearest hundredth for this term right here, it's likely you will get this part wrong. That's why the storage value is pretty important. So whatever m was, does anybody have a value for it? You had to store it, so you must have it in there somewhere. What is it?
90.
To the nearest hundredth? What?
Well,
I have
what I got, then
In order to store that, you had to have the value in your screen somewhere.
I got 15.98. I'm not sure if it's right.
Store stove. Dough out the air.
This is the thing, if you get the slope wrong, it's likely you will get the answer wrong. So hopefully, and by the way, the one that you have to do on the test isn't nearly this hard. 4 square root
15.98.
3 pi squared
That's good to know.
divided by 9 plus 8 pi divided by 3. Order of operations says I don't need very many parentheses, so yeah, I get 15.98 as well. Is that right? Okay, so right here we can write 15.98 x
15.98.
That's what we all just said.
Yes.
Okay. That was really awkward.
Okay, so if I store that in A,
I'm glad I didn't.
Who's crunchy?
then I would take A times pi divided by 3 plus 4 pi squared divided by 9, and I would get 21.12. Is that right? Is that correct?
Yep.
That's the answer you should look for. Because they will have it in approximate form, but you don't dare approximate until the very end. Be sure to show me your work so that if you get some of this wrong in here, I can at least see what your intention was.
It's all multiple choice, right?
Yes.
All multiple choice, but he's got great distractors and people routinely choose the wrong one. And you know.
And we can do the second guess thing, like, oh, this is our
Yep.
backup.
Yep,
Why is that allowed?
Because it's calculus.
because I called shots and you're my
Jacob
calculator.
shouldn't get that though.
Because these distractors are really good. That's why. Okay, number 6. Again, find dy dx if y equals, and this time you will have to use the chain rule to get the correct answer. It is a trig function of a polynomial. So, this. Let's say that I ask you to find the dy dx for this. Y equals the negative cosine of 3x cubed minus 2x squared plus 4. What's y prime going to be, dy dx? Good.
Oh.
Sine of?
Sign of the good stuff.
That's the good stuff.
Times 9x squared minus 4x.
And that's it. Yes.
If this were the case, if this were it, all of your answers will be offered in this form. They will put this on the front.
So you don't even have to distribute that?
You can't. Because this is behind the sign. You can't distribute it through there. It's not this times this. It's the sign of this times this. That's it. That's the type of answer you're going to be offered. Number 7 is that parametric one that we talked about earlier. The last one, number 7, is a parametric one where you have to, it says, a curve is defined parametrically by, and it gives you x equals and y equals, find dy dx at a point when t is equal to a value. So you only have to find the derivative. You don't have to find the equation of the line. Just the derivative,
So we
evaluated at a t value.
find the derivative of y over derivative of x at this value.
Wait, what do you mean?
Oh, that was confusing today, but I got it.
Work on that worksheet, okay, Axel?
Okay.
All right.
Could have been one of those. It could have been like.
Okay, Savannah, end of the line. Bye.